Virtual reality and real-world perception, an examination of spatial awareness and proprioception by Dinang Bista, Niriksha Regmi, and Swampu Zhang. The main motivation behind this study is to see how users' proprioception plays into account when there is an interplay between virtual and real world. Nowadays, passive haptics have become really popular. For example, when there is a VR system that's teaching about surgery training, interaction between physical objects becomes mandatory because of the complexity of surgery related teachings. We are trying to see how bodily awareness and position of a real world object when subjected to a virtual reality experience accounts for a user. We are trying to see if providing audio cues from the real world also guides the user or not. Here's our system demo. Users were asked to touch a real world bottle with a controller. Then they put on the headset, and in the headset they saw a virtual world bottle that was perfectly aligned with the real world bottle. They picked it up and placed it at different locations on the table. The table was perfectly synced with real world table. After doing this, they were asked to perform a side task. The side task was to build a castle using block pieces to their left. With each incorrect move, score decreased. With each correct move, score stopped decreasing. Score started at 100. This was a side task just to keep the users engaged. Case 1. After completing the task, users turned to their original position. The virtual world position of the bottle was different while the real world position was the same. Now they were asked to touch the real world bottle using their controller. Case 2. Once the task was completed, users oriented them to their original position. Then the virtual world kept shaking and producing a sound from the real world. Then users were asked to touch the real world bottle. Here's the data of the people. There was a mismatch between 3 users who did not touch the bottle in the case of disorientation, while 5 users touched the bottle. While in the case of the audio, 6 users did not touch the bottle, while 2 users were able to touch the bottle. Here's a stacked bar graph showing the results. We found out that 7 people touched the bottle while 9 people did not touch the bottle. Yes, people are able to find the real world position of the bottle. However, we thought that providing audio cues would help the users, but instead it further confused the people and the people could not find the position of the bottle. We also calculate the p-value using Fisher's exact test. Thank you.